Okay, in this problem we're asked to find the change in the shopping distance of a vehicle using this formula. We are given x1 and x2, which is 35 miles per hour, and x2 is 37 miles per hour. So first, we found the derivative of the formula, which is 2.7 plus 0.8x, and we know that the rate of change is of 2 miles per hour. We found this by using this formula of subtracting x2 minus x1, which was 37 minus 35 equals 2. So we know that the rate of change of x is of 2 miles per hour. Then we simply substituted in the formula the x2 and the x1, and we found these were the answers, and at the end you just apply this formula of the rate of change equals x2 minus x1, which is what we did here, and we found that the rate of change in the shopping distance of the vehicle was of 63 feet. Then we were asked to find the percentage of change. So we put x2 over x1. We know that x1 is 100%, which is because the vehicle started at this percentage. So we took the x2 from here and the x1, divided them, which gave us this decimal. We converted it to percent minus the 100%. Again, x2 minus x1 is the rate of change, and we found that it was 10.778%.
So now in letter C, we're asked to find the same thing we found in letter A, but with differential. So we approximate the answer. It is a simple formula that the change in t, or in the miles, is equal to the formula, like the derivative of the formula, times dx. So we know that the derivative of the formula is this. And so we substitute x1 here, and dx is equal to the change in x, which is 2 miles per hour. So after substituting, we get 61.4. Only to have some assurance, we did it with the x2, which we know is correct since the average of both answers is 63, which is the same as the increment. And when asking letter D, what does the percentage mean? It means that when the change of x equals 2, it means that there's a difference of 10% in the traveling distance. So we know that for every extra mile, we have a 5% increase in the distance, and also that the average of each distance in t approximated is the increment, so it is a good way to know when you're right.
So we're going to do this problem, which is a problem where you have to do the antiderivative, and you know this because you have this symbol which is telling you to do the antiderivative. So in this problem, since the parentheses don't actually have an exponent, we need to do FOIL first. So you're going to multiply every number by the one on the other parenthesis, and you're going to get this answer. Okay, and then the next step is to actually find the antiderivative, which is pretty simple. You simply have to add 1 to the exponent, and then this new exponent needs to be divided by the whole number. So in this case, the 140 will be divided by the new exponent, which is 25 over 6, and you will get the following numbers. And this is a version in which we haven't actually simplified yet, but an important part is that in this situation, x actually is -1, and if we were to add 1, we would get x is 0, which is impossible. So in this case, you have to write the number, ln, and whatever is x, place it in an absolute value lines. And always remember to, when you finish all of this, to place c instead of dx. Instead of dx. So here we have the non-simplified version of all this problem already resolved, and then the final answer, which is already simplified in here.
And another way of placing the ln is this way. So instead of placing the number and the x in the parentheses, you just place ln, and the number that was before the ln, you place it as an exponent on the x.